making this current flow in this circuit I. Okay, so I told you it will always starts from higher, like it will always flow from higher potential to lower potential. Okay, now here it will get divided into these two parts, I1 and I2. Okay, so if it is going like this, the polarity is already mentioned here, plus and minus. Okay, so this is my one circuit. Here again, if current is going like this, it should be from plus to minus. This is minus, this is plus, plus minus, and this is again plus minus. Okay, now KVL states that when we talk about KVL, it states that in a closed circuit, the summation of all the EMF sources plus the voltage drops across the elements in the closed circuit is equal to 0. That means they talk about summation of EMF sources, okay, the energy sources or the battery, and they too talk about the voltage drops that I can have in my circuit. So that summation should always be equal to 0. Okay, so for this equation to write, and when we have this summation symbol here, so here we have to also consider the direction associated with this particular equation. Okay, so I told you this is plus and this is minus. So what I'll do, I'll start in anti-clockwise direction. Okay, so for that I'll write all the voltages as per their, like if it is going from positive to negative, it will be considered negative. It is going from negative to positive, it will be considered positive. You have to just remember this. Okay, that too with a logic, like from higher to lower it is going, so it is actually drop. And from, if it is going from lower to upper, so it means it is a rise in potential. So rise is associated with plus sign and drop is associated with minus sign. This way you have to remember this. Okay, so when I write the KVL equation for this particular part of circuit, it is nothing but 100. So this is again from plus to minus. From plus to minus is negative. So minus, this is IR drop. So I is I here, R is 40. Okay, then again I'll come back downwards. So again it is from positive to negative. Okay, but what is the current? So when we talk about this particular part of the circuit, you can see that this is an open circuit. Okay, so current flowing in this part of the circuit is always 0. Okay, so the current flowing in this part of the circuit is always 0. So I showed you that in this particular node it has two ways to move, but as soon as this current will reach at this point, it is not having any path to flow. So this is an open circuit condition where my current value is 0 across this particular part of the circuit. Okay, so that means I am talking about the same current that is flowing in this circuit. Okay, so that means I amount of current will entirely flow in this circuit, because here this is open circuit, so this I1 will become 0. Okay, so this I is nothing but this I2. So all current will flow in this circuit. Okay, so what is that? So I multiplied by 60 with a minus sign. Why? Because again it is going from plus to minus. Plus to minus is drop. Drop is associated with negative sign. So minus I into 60 equal to 0. So this 100 is equal to 100 I. So I value I am getting as 1 amps. 1 ampere, sorry. Okay, so 1 ampere of current is passing in this circuit. Okay, now this is V1. We know that if I know the value of current and voltage, I can calculate V1. Current I have calculated as 1. Resistance is given as 60. So that means V1 is nothing but 60 volts. Okay, so here we have 60 volt. Okay, similarly, if you multiply 40 with 1 ampere, it will be 40 volt. So you can see here in this circuit, 100 volt divided between 40 and 60 ohm resistor, where 1 ampere of current is flowing. So you can see that rise in potential is exactly equal to summation of drop in potential. Okay, 60 volt, 40 volt. So here we will have 40 volt. Here we are having 60 volt. So this value is correct. Okay, now what about this VAB? Okay, so I'll just remove everything. Okay, So now when we are talking about VAB, so this is a closed, like when I use this closed word, actually it should be connected. Okay, so I used an incorrect word. But when I talk about an electrical circuit about which I know each and every dimension in terms of voltage, like I'm talking about this part of the circuit. Okay, and that part also includes this part. Okay, so when we talk about open circuit, okay, so here when a current is trying to flow in this circuit, as soon as it reaches this point, okay, current doesn't have any path to flow. So when we talk about open circuit, here my value of current is 0. But these are the two end terminals of my open circuit. Okay, I will always have a voltage across between these 2 points. Current is 0, that like if you think like this, that V equal to IR. So if current is 0, whatever is the resistance, voltage will always also be 0. You don't have to think like that here. Here when you talk about open circuit, that open circuit is some way or the other connected to some other voltage or some other potential. So that potential, and if we can apply that in form of an equation, we can find out that unknown quantity. Okay, so current is 0 because of very large amount of resistance, but voltage is always non-zero. Okay, you always think like in open circuit current is 0, so this is very general. But students also think like if current is 0, we should also be 0. No, we'll always have a voltage across the open end terminals. Okay, so we'll just try to see this. Okay, we'll solve this problem. Okay, so this V1 value I know, which I have calculated at 60 volt. Here my current passing is 1 amperes. Okay, so that accounts for 40 volt of voltage drop across this point. Okay, so when I talk about this part of the circuit, okay, I just marked. So again for you, this part of the circuit. Okay, so let's try to apply KVL here. Okay, so okay, so I'll start with this and I'll move in clockwise direction. Okay, so I'll move in clockwise direction. So this is my direction. So this is when I'm going moving like this is going from negative to positive. Okay, you're just getting this. So for you, positive to negative is always from higher to lower. So drop. Okay, from if it is going from negative to positive, so that means it is going from lower potential to higher potential. So this is
Yes.
rise. So rise will always take as positive and drop will always take as negative. Okay, you have to just understand this. All is display, nothing else. Okay, so when I'm going like this, so this is going from minus to plus. So minus to plus is rise, so this is positive. So this is V1. Okay, and we have already calculated this value of V1. Okay, that is 60 volt. So plus 60. Now it is going like this. What should I write for this? Question for all of you. What should I write for this in a KVL equation?
So 0,
Why?
because current is 0, so the resistor will not have an effect.
Okay, so current is 0. So there is no voltage drop across this part. Very good. Okay, so there is no voltage drop across this part. Now when it is when I'm trying to follow this part, this is again negative and positive. So from negative to positive, it is always rise in potential. So we take it as positive. So positive 30. Again, now we are going from plus to minus. So plus to minus is always a drop. We take that as negative. So negative of minus VAB. Okay. Now again, if I am moving like this, so this at this point I am going from plus to minus. So plus to minus is always drop, that is negative. So minus 10 volt now. So this is V volt, this is volt, VAB 10 volt. Okay. So now the circuit is again from where we have started. So summation of all these is equal to 0. So your equation when you will write an exam or when you will solve, what is the practice? That applying KVL in, okay, so you have to name at that point A, B, okay, this is not good, okay, X, Y, Z, W, okay. So applying KVL in loop, don't write loop, okay, applying KVL in closed path Y, A, B, Z, Y. So this is a closed path I am talking about. And then you will write this as 60, this is 0, this is again 30 is plus, this is from plus to minus, so minus VAB, this is from plus to minus, so minus 10 equal to 0. So this is 90 minus 10, 80, and VAB that side, so VAB equal to 80 volt. So see what looked like an open part. So current is 0, so voltage should also be 0. But when we actually calculate, you can see that you will always have a voltage across open circuit. Is it clear, students? Are you trying to get the logic now? What we have to do?
So
Clear, sir.
why do you ignore the voltage of the resist, like the 10 volt resist, 10 ohm resistor?
This one,
Yeah, yeah.
because voltage is always I into R. Okay. So in this circuit, we know that this is an open circuit. So no amount of current can pass in this part of the circuit. Okay. Yes, when this is a closed circuit, we saw that 1 ampere is passing through everything. But as soon as this 1 ampere will try to go to this part of the circuit, this circuit doesn't have a path to flow. I mean to say, here is an open path where cannot flow. So this entire amount of current will come out to be 0. So voltage drop will come out to be 0. Did you get the logic?
Yes, sir.
Okay. So this is like a way like how we can approach a particular problem. Okay.